The next concept in the mathematics of counting, combinatorics, that's useful is permutations. So I'll start this one off with just an example question. Let's say 7 people run a race at the Olympics. In how many ways can the gold, silver, and bronze be awarded? So again, let's start with the pigeonhole principle. The first person to cross the line gets the gold medal. There are 7 people running, so there's 7 possibilities there. Now, once somebody has crossed the line, there are now only 6 runners, and there are therefore 6 people left who could take the silver. And finally, once 2 people have crossed the line, there are 5 people left. So we end up with 7 times 6 times 5, which is 210. Now, another way to symbolize this would be to use the symbols for permutations. There isn't really a special symbol, but they use the letter P with 2 numbers on either side of it. The way to represent this would be 7P3. So the 7 means that we have 7 objects, in this case 7 runners. And we want to find the number of permutations of a subset of those 7, in this case 3, because there are 3 medal winners. So 7p3. Now, in the red box to the side is the formal definition for permutations. NPR is equal to n factorial over n minus r factorial. You really don't ever need to know this. And the reason is because 7p3, the easy way to calculate this, is just to start writing 7 factorial and only write 3 numbers. So starting with the 7, 7 times 6 times 5. And again, that's equal to 210. So the reason this works is because, let's say we used the formal definition for 7p3. So we have 7p3 is equal to 7 factorial over 7 minus 3, which is 4 factorial. And recall, 7 factorial is just 7, 6, 5, 4, 3, 2, 1. And 4 factorial is 4, 3, 2, 1. And so we're always going to have this match. The 4s, the 3s, the 2s, and the 1s disappear. And we're just left with 7 times 6 times 5. In other words, the first 3 numbers of 7 factorial. So it's always pretty easy to calculate permutations. The numbers might get a little big, but it's pretty easy calculation. Now, it's really crucial when you go to apply permutations that you're applying it correctly. And the big distinction between permutations and what we're going to see next, combinations, is that with permutations, order matters. In the example I gave, the gold is definitely different from the silver, is definitely different from the bronze. You're not just giving away 3 medals, you're giving away different medals, and so it matters the order in which they finish. Let's take a look at another quick example here. 10p4. How do you interpret that? Well, the 10 means there are 10 objects. The 4 means you're going to take a subset of 4 of them. So you're going to order those 4 objects. How many ways can you order the 4 objects taken from a larger set of 10 objects? Well, again, to calculate it, all you need to do is start writing 10 factorial and only write 4 numbers. 10 times 9 times 8 times 7. And it's a large number. You might want to pull out the calculator, but it's easy to calculate. 5,040. So that would be the number of ways of ordering 4 objects taken from a larger set of 10 objects. Much bigger number than just simply ordering 4 objects, right? The number of ways of ordering those 4 objects is 4 factorial, which is just 24. But if you're taking it from a much bigger set, you get a much bigger number, 5,040 in this case.